Okay, next is question number 19. The diagram shows a crane lifting a load. There is a large mass called a counterweight attached to the crane on the opposite side of the tower to the load. Okay, so you can see on the figure, there is a beam. Basically, this is a crane. So load is there, counterweight is there. This is the tower. Okay, so part A is asking here that the crane has an electric motor with an efficiency of 47%. The efficiency is given. The crane lifts a load of 4.4 times 10 to the power 4 Newton. The weight of the load is given. The load moves through a vertical distance of 15 meter in a time of 70 seconds. Okay, so it has been moved through a vertical distance of 15 meter in 70 seconds time. So the question is to determine the average power input to the electric motor. So we need to find out the average power input. Okay, so efficiency, right? So efficiency, it is equals to what? Efficiency, it is equals to power output over the power input, right? So we need to find out the power input. So for that we need to know the power output and the efficiency, right? Efficiency is given. So let's figure out the power output. So power output, this is what? Rate of energy transfer, right? So this is what? Weight times the distance traveled, right? That is Fs. So in that case it is mgh. So mg is 4.4 times 10 to the power 4 times what? H is 15 meter. So 15 over the time is how much? Time is 70 seconds. So that would give you how much watt? The unit for power, it's what? Watt. So 4.4 times 10 to the power 4 times 15 over 70. So that would give you 66,000 over 7 watt. Okay, so we got the power output. So we need to find out the power input. So in that case we will take efficiency to the denominator. So you will get 66,000 over 7 divided by 0.47, 47%. Okay, that much watt. So answer, that is the power output. Answer, divide 0.47. So that would give you 2060. So this is basically 2060. Okay, it's not 2000. Okay, it's 20,000. 20,060.79027 watt. Okay, so we can consider it as how much? To three significant figures we can write it as 20,100 watt. Fine. So average power input, it is how much? 20,100 watt. That's it. That's the answer for question number 19, part A. Fine. Okay, next is part B of question number 18. Okay, so in question number, okay, this is question number 19, not 18. So here in part B of question number 19, it says the horizontal distance from the load to the tower can be changed. The horizontal distance from the counterweight to the tower can also be changed. So basically the distance of the counterweight and also the load from the pivot, it can be adjusted. Okay, so part 1 of question B, it's asking to explain how the counterweight needs to move when the load is moved away from the tower. Okay, so how the counterweight should be moved. So this is, look, this is for 4 marks. So definitely you should be aware of the marks of each of the question when you are answering them. Okay, so what we can say at first, for 4 marks, definitely we need to explain it very well, isn't it, to get full marks. So at first we will consider the fact here. The fact behind this question, it's what? It's related to moments, right? So the main case here is that, the main fact here is that the system should be in equilibrium, right? the beam should not rotate in any way, right? So in that case, the first point what we can say here is that what? To keep the beam horizontal, okay, total clockwise movement should be equal to what? Total anti-clockwise movement, right? Anti-clockwise movements. Okay, this is the first concept. 1 mark. Next, second point is what? Now consider what is providing the clockwise movement here and what is providing the anti-clockwise movement here. So the clockwise movement, it is provided by the load and the weight of the beam, right? So let's say the beam is uniform, so it acts from the middle, right? So the clockwise movement, it is provided by the load and the weight of the beam, right? So total Okay, next is part 2 of question B from question number 19. Okay, so here it says the beam is uniform with a weight of 3 times 10 to the power 4 Newton. The counterweight has weight of 1.1 times 10 to the power 5 Newton. The load has weight 4.4 times 10 to the power 4 Newton. Deduce whether the load can be moved to the end of the beam without the crane toppling. Okay, so the load has to be moved at the end of the beam. Okay, so if you consider the load is at the end of the beam, so what would be the distance from the pivot? The distance from the pivot, it would be, let's consider the total length of the beam. Do we know the total length of the beam? Okay, it might be given here. Okay, the counterweight, it's at a distance of 8 meter from the pivot, and the beam, the load, it's what, 30 meter from the pivot. It is 22 meter. Okay, so in that case, at first consider, look, when the load is at the